We want to take a look at the solution to some quadratic equations where we solve them by what's called completing the square. Here's our first one. We have 5x plus 2 quantity squared is equal to negative 8. Now, to solve this equation right here, we say if the quantity 5x plus 2 squared is negative 8, then 5x plus 2 must be either the positive or the negative square root of negative 8. So we go from this expression down to this expression, and that gets rid of that square that we have on the 5x plus 2. So if 5x plus 2 quantity squared is negative 8, then 5x plus 2 itself is either the positive or negative square root of negative 8. Now we'll simplify this. 5x plus 2 is equal to plus or minus. When I simplify this expression, I get 2i square root 2. So the negative sign under the radical gives me an I outside, and 8 is 4 times 2. The square root of 4 is 2, so I have 2i square root 2. Now I'll simply add negative 2 to both sides and then divide both sides by 5. That will give me x equal negative 2 plus or minus 2i square root 2 all divided by 5. And these are my two solutions to this equation right here. Negative 2 plus 2i square root 2 divided by 5, and then the other solution is negative 2 minus 2i square root 2 over 5. Let's look at our next problem. A squared plus 10a plus 22 is equal to 0. Now what I want to do is get this equation right here in the form of the equation we solved in the problem number 1. So I'm going to start by writing these first two terms together on the left side and moving the constant term to the other side by adding negative 22 to both sides. So I get negative 22 on the right side. Now I look at these first two terms as if they're the beginning of a perfect square trinomial. I have 1a squared plus 10a plus, now I'm going to add on my own third term right here so that this becomes a perfect square. So I take half this coefficient, half of 10 is 5, and I square it. That gives me 25. If I add 25 to one side, I also add 25 to the other side. The reason I did that is so that I can write this expression as a plus 5 quantity squared equal to negative 22 plus 25 is 3. Now I'm down to an equation that has the form of the one in problem number 1. So a plus 5 quantity squared is 3. That means that a plus 5 itself is plus or minus the square root of 3. Now I add negative 5 to both sides, and I get a is negative 5 plus or minus square root 3. So this is what the two solutions look like to this equation right here, and I found them by a process called completing the square. Move the constant term to the other side, then I take half the coefficient of the linear term, square it, and add it to both sides. That guarantees that this side is a perfect square trinomial, and then I simply apply this theorem here that says that if a plus 5 squared is 3, then a plus 5 itself is either the positive or negative square root of 3. That allows me to solve the equation. Let's look at our next example. This time I have 2x squared minus 4x minus 8 equals 0. I need to do two things. I need to get rid of this constant term on this side, and I also need to make this coefficient of x squared 1. So I'm going to divide both sides by 2, and then I'm also going to add the opposite of this to both sides. When I do that, I'll end up with x squared minus 2x is equal to positive 4. So I divided everything by 2. That gives me x squared minus 2x minus 4, and then I add positive 4 to both sides, so I have this. Now I'm going to complete the square by taking half the coefficient of this term, so negative 2, half of that is 1, squared is positive 1. So I'll add positive 1 to both sides of this equation. On the left side, then, I have guaranteed the perfect square, x minus 1 quantity squared, and on the right side I have 5. Now if x minus 1 quantity squared is 5, then x minus 1 itself is either the positive or negative square root of 5. Add 1 to both sides, and I have 1 plus or minus square root 5. So there's my two solutions to this equation right here, and I found them by this process called completing the square. It requires that I make the coefficient of the squared term 1, move the constant term to the other side, and then complete the square by taking half the coefficient of the middle term, squaring it, and adding it to both sides.